in coordinate geometry. And so if you notice the following, it says find the distance between these 2 points. So in order to find the distance between these 2 points, does anybody have any ideas?
Does it rise or fall?
That's the slope. Yeah, what we can do is we can make this a right triangle. Okay, and by making it a right triangle, I can then apply the Pythagorean theorem to find the length of the red. I know that the horizontal length here is 2. I know that the vertical length is 4. So in order to find the red, I'm going to take 2 squared plus 4 squared, and that's going to equal, we'll just call it c squared.
Oh, I forgot my calculator.
So 2 squared is 4, 16. So I end up having 20 here. To find that, I'm going to take the square root of both sides. So I take the square root of 20, which is 4.47. And so that is the distance between those 2 points. Just the Pythagorean theorem. Now, what happens if the 2 points are so far away that we can't plot that in a right triangle form? Okay, we'll get to that. Okay, for right now though, let's go ahead and look at this one. Once again, let's go ahead and do a right triangle. What do you get for the horizontal distance there?
8, no,
6.
1, 2, 3, 4, 5, 6. Vertical?
2.
2. So I get 2 squared plus 6 squared equals c squared again. 2 squared, you know, is 4. 6 squared is 36. So I end up getting 40 to equal c squared.
It's going to be like
6.32.
Yeah.
6.32 will be your distance. Okay. So let's look at the next statement. Whoa!
Oh, yay.
8 by 2.
Okay, so that's 8 by 2. You said, so I've got 2 here, 8 here. So I have 2 squared plus 8 squared.
8.25.
Okay, so I end up getting, try again, 68. So when you take the square root, you end up getting, you said 8.25. So gradually, you can see we're getting bigger and bigger and bigger. Okay. Likewise, again, think you can handle that?
Yes.
Okay.
Oh.
So now, what happens when we don't have a visual?
Die.
What happens when we don't have a visual and we're just given 2 points? I mean, am I going to take graph paper and draw out 2 points, 8, 15, and negative 7, 23? Chances are probably not. So there is a way that we can do this in general, and we're going to generalize this for every set of 2 points. Hey, and you wanted the men's section, right?
Yeah. Wait, guys can't even order women's, can they? Who would do that?
Are we still recording?
In small, yes.
Well, I'm checking because some of them are female and ladies, some of them are women. I'm one of the men's. Yeah, I am too.
I guess if someone, no one's small though. I'm probably the smallest one, and I'm one of them.
So now this is what you're going to do. This is going to be the square root of x2 minus x1. And this is going to be the square root of y2 minus y1. So essentially what you're doing is you're subtracting the x-coordinates. And you're subtracting the y-coordinates. And you're just applying the Pythagorean theorem. Okay, so find the distance between A, which is at 8:15, to B, which is at negative 7:23. So if I want to find the distance between A, B, that's going to be the square root of. Now what I'm going to do here is subtract the x's. And it doesn't matter which one you start with first. I could start with A or B. I'm just going to go ahead and start with the second just because that's generally what's done. So I'm going to take negative 7 minus 8. So all I've done is take this minus this. Now I'm going to do the same thing for the y's. So I'm going to take 23 minus 15. So instead of having to plot them out, I can just do this. Let's go ahead and calculate. Here I get negative 15. Here I get 8. So I end up having the square root of negative 15 squared, which is actually 225. Now, by the way, you should never get a negative. If you get a negative when you square something, you've done something wrong, because remember, whenever you square something, it becomes a positive. 8 squared is 64. So if you had 225 and 64, what do you get? 289. So the square root of 289 is 17. There you go. So that is the distance between those 2 points. Now, will it always be even? No. It'll be like those problems before that we had to round. So, questions? So with that in mind, let's go back to this one and let's look at the points. The point here is 4, negative 4, right? The point here is negative 5, 2. So if I was going to use the distance formula, this is how I would use the distance formula.
That's 3 negative 4.
3 negative 4, sorry, I missed that one. Okay, so we'll change that one to a 3. I'll just get rid of it totally and then we'll try. Okay, so to now apply the distance formula here, that's going to equal the square root of, so I'm going to start with my x's. So 3 minus what?
5.
Negative 5 squared. Then what I'm going to do is I'm going to add negative 4 minus 2 squared. 3 minus negative 5 is 8. Square it, you get 64. Here, negative 4 minus 2 is negative 6. Square it, you get 36. So I end up getting the square root of 100, which is 10. Okay, so what's happening is you're subtracting the x's and the y's, you're finding the horizontal and the vertical parts of your right triangle. Questions? There's your assignment, 1 through 10, numbers 12 and 13 on page 504 through 505. Due tomorrow. Okay?
Well, I'm pretty excited.